Last section we looked at vectors in their column vector form. So the column vector form had this kind of look about it. Now we're going to look at vectors in terms of rectangular components and the 3 unit vectors. Now there are 3 unit vectors in each of the directions in the plane. Now we've got the ones that we're familiar with. So in 2 dimensions we've got the x and the y. Okay, in 3 dimensions, I want you to think about this as being like a plane, okay, like a surface like that, so that you've got x and y, so x going along here, and then y, so it's like a piece of paper, and then you've got another axis, it's like poking through that piece of paper, so it would go through the paper, up and down, and it's perpendicular to each of these other directions, and that's the z-axis. So this is in 3 dimensions and this is in 2 dimensions. Now when we talk about unit vectors, a unit vector is a vector that has 2 particular things that are important about it. One thing is that it goes in, well, for us with the I, j and k, it goes in one of these 3 directions, z, y or an x, and it also has a length of 1 or a magnitude of 1. Okay, so a unit vector is very important because it has a magnitude of 1 and it basically helps us to find our direction. Okay, so if we were given some other length for a vector, like say we needed a vector to be 2 long, but we knew what direction it had to be in, we could take that magnitude of 2 and times it by the unit vector. That would give us the right direction. Remember, a vector only needs 2 things, a magnitude and a direction. So the unit vector will give us a direction. You can also have unit vectors in any other direction apart from these 3. But the ones that we're focused on here are the 3 key unit vectors. They're I, j and k. I goes in the x direction. It has a length of 1. Okay, so we call that the I unit vector. J goes in the y direction, and again it has a length of 1. So that would be I and j. And the last one, k, goes in the z direction. Okay, so we're going to be measuring or making up all of our vectors using I, j and k. So depending on where that vector sits, it will be made up of I. Like say we had a vector that was 2 across. I'll draw one. If we had a vector that sat here and was 2 across the x direction, this vector would be 2i. And we can show that by using a little hat on the top of the I. It's called a hat because when we put that on top of a vector, it tells us that it's a unit vector. It has a length of 1. And any vector can be made into a unit vector by dividing by its magnitude. So if you can imagine having a vector that, like for example this one here, 2i, if we divide that vector 2i by its magnitude, which is 2, we'd get ourselves a unit vector just in that direction. So anything with a hat on the top is a unit vector, so that's why we tend to use a little hat on the top for I. You may also see in the textbooks too that they use a little swirly or tilde underneath the I, j and k, or they use it in bold, but I'll use the little hat on the top. So that's what unit vectors are in each of the directions. This is the representation as columns as well, so you can see that the I is just 1 in the x direction, j is 1 in the y direction, and in 3 dimensions, that's why we've got the extra line here, k is 1 in the z direction. In terms of magnitudes, the magnitude of a vector is given pretty much like we looked at in complex numbers. So remember we had like the real part squared and the imaginary part squared. Well, this is the component in front of I squared plus the component in front of j squared, square root of that. It's Pythagoras, because if we have a look at the picture here, if we have an I and a j and some vector made up of i's and j's, it's a triangle. So we've got one side is I, one side is j, and then we square each of those sides. To get that third side, the hypotenuse, we'd do the square root of these. So it would be the x that was going in that I direction and the y that's going in that j direction. So we don't square the I and j's because I and j have a length of 1. We square how far we're going in the I and j directions. That's why we have the x squared and the y squared. Same in 3 directions. So we would square what's in front of the I, j and k, and we take the square root of that. So it's Pythagoras in 3 dimensions, squaring this part here, how long we've gone in the I direction, how long we've gone in the y direction, and how long we've gone here in the z direction, and then the square root of all of those. So it's really important to remember your formulas for magnitude as well. Definitely write down a unit vector, the definition of a unit vector and its formula, and write down the definitions and the expressions for magnitudes.